In this lesson, we're going to look at several applications that involve rational equations. A company is planning to manufacture small canoes. Fixed monthly cost will be $20,000 and it will cost $20 to produce each canoe. We want to write the cost equation C of producing X canoes, write the average cost equation A of producing X canoes, and then find out how many canoes must be produced each month for the company to have an average cost of $40 per canoe. Let's take this one step at a time. The first step is to write the cost equation of producing X canoes. Well, I know that it's $20,000 and it costs $20 per canoe. So my cost equation is going to be C is equal to 20,000 plus 20X. To find the average cost, which is going to be our next step, all we need to do is divide by the total number of canoes that we're going to produce. Because whenever we take an average, we'll take the sum of everything that we have and divide it by the total number of items that I added together. So my average cost is going to be 20,000 plus 20X divided by X. Lastly, I want to figure out how many canoes I must produce each month for the company to have an average cost of $40 per canoe. So my equation here is I'm going to set my average cost equation that I found in step B equal to 40. This is a proportion, and a proportion we could always solve by cross multiplying. So 40 we know is really 40 over 1. So I have 40x is equal to 20,000 plus 20x. I could subtract the 20x from each side. So I have 20x is equal to 20,000. Divide each side by 20. So x is equal to 1,000 canoes. So in order for the average cost to be $40 per canoe, the company needs to produce 1,000 canoes. In our next problem, a hurricane strikes in a rural area is without food or water. 3 crews arrive. One could dispense needed items in 10 hours, a second in 15 hours, and a third in 20 hours. How long will it take all 3 crews working together to dispense food and water? So what we're looking at is all 3 of these crews, crew 1, crew 2, and crew 3, working together to complete one job, and that's to dispense food and water to this community. So we're going to start by picking a variable. For simplicity, let's just use x. X is going to represent the number of hours that we need to complete the job. Next is figuring out how long it's going to take each of those crews. Well, I know that the first crew can dispense items in all those items in 10 hours. So that means every hour that passes, so every X hour that passes, 1/10 of their job is complete. So crew 1 has a rate of 1/10 times X, because 1/10 of the job is done every hour. When I have 10 hours, I have the entire job completed. For my second crew, their rate, since they take 15 hours to do that same exact job, would be 1/15 times X, since they get 1/15 of the job done in one particular hour. Lastly, my third crew is 1/20 times X, since in 1 hour they will have 1/20 of their job completed. So my equation here is going to be x over 10, the rate of the first crew, plus x over 15, the rate of the second crew, plus x over 20, the rate of the third crew, and it's going to equal 1 because we have one job that's being completed here. Okay, since this is not a proportion, we're going to solve by just multiplying through by the LCD, which is going to be 60. So every single term on both sides of the equal sign get multiplied by 60, because it's just a way of rewriting the equation without actually changing the meaning of the equation. So once I multiply through and simplify, because we know that 60 is going to end up canceling out those denominators, that's the whole point of multiplying by the LCD, we're going to be left with 6x plus 4x plus 3x is equal to 60. Don't forget to multiply that right-hand side of your equation also by the LCD. If you forget to do that, you're going to end up with really strange answers that don't make sense. Adding all of this together, we have 13x is equal to 60. Dividing by 13, we're going to get x is equal to about 4.6. So that means because x represents the time that it would take all three crews to get the job done working together, all three crews can get the job completely finished in 4.6 hours.